We'll close off this module by exploring a little bit more detail a toy example of decision trees and comparing it to our example of logistic regression from before. Here's the example that we're going to consider, is one that we considered in the logistic regression module. We're taking this data set here and fitting a logistic regression. Decision boundary is on the right here, and we can see the parameters that we learned from data. So this is if we just did a simple degree 1 polynomial features, just kind of straight up linear features. Let's see what happens when we build a decision stump on the same data. So if you do a single level decision tree and you apply it to this data set, what we'll do is we'll split on x1, and if you try out the threshold values, you'll see that on the left side we'll have x1 less than minus 0.07, and on the right side it will be x1 greater than minus 0.07. You see for the ones on the right, we have more positive examples, so we're going to predict positive, while the ones on the left we have more negative examples, so we're going to predict negative. And you'll see that they correspond, so here's our split, minus 0.07. This first left node of the tree will correspond to points on the left there, and the second one will correspond to points on the right. Extremely intuitive. So unlike logistic regression where we're able to get a diagonal decision boundary, here we're only going to get straight up or straight across decision boundary, at least in the first split. Now if we keep going with the greedy algorithm and we take another split for each one of these intermediate nodes, we'll see that for the data where x1 is less than minus 0.07, we might split on x1 again and make predictions, which in this case will be splitting on x1 less than minus 1.66, and on both cases we're predicting to be minus 1, so a negative data point, so minus 1, but for x1 greater than minus 0.07, we now split on x2, whether it's bigger than or greater than 1.55, which in our split on our data is over here, 1.55. That's what x2 would be. And we see that now we have, for the data which is smaller than 1.55 in x2, we have 11 positive examples, so we predict +1. But for the data which is greater than 1.55, we have 3 negative examples, so we predict -1. And so now we have a much more interesting region. So the splits, so there's two nodes here on the right. One corresponds to this big green area, and the other one corresponds to this little box on the top. And we can imagine continuing this process, splitting again and again and again, as we'll see next. But one important thing to know is that when we have continuous variables, and this is a really important point, unlike for discrete ones or for categorical ones, we can split on the same variable multiple times. So you can split on x1 and split on x1 again, or you can split on x1 and on x2 then on x1 again. And we'll see that. So in this example that we talked about, we can keep the decision tree learning process going. So in depth 1, we just get a decision stump, which corresponds to the vertical line that we drew in the beginning, minus 0.07. If we go to depth 2, we get this little box that contains most of the positive examples, but there's still some misclassifications over here. And then if we kept going, splitting all the way to depth 10, we get this really crazy decision boundary. And if you look at it carefully, what you'll see is that, and I'm going to draw over the decision boundary here, but if you look at it a little bit carefully, you'll see that it basically makes no mistakes. So it has 0 training error. And we can compare what we saw with logistic regression with what we're seeing with decision trees and understand again and preview for what we'll see in the next module, kind of the notion of overfitting. So in logistic regression, we started with degree 1 polynomial features, and then we saw that degree 2 had a really nice fit of the data. It's a nice parabola. It didn't get everything right, but it did pretty well. And then a degree 6 polynomial was, had a really crazy decision boundary. It got 0 training error, but I didn't really trust those predictions. We didn't really trust those predictions. The decision tree, what you control is the depth of the decision tree. And so depth 1 was just a decision stump. It didn't do so well. If you go to depth 3, it looks like a little bit of a jagged line, but it looks like a pretty nice decision boundary. It makes a few mistakes, but it looks pretty good. If you look at depth 10, you get this crazy decision boundary, has zero training error, but is likely to be overfitting.